Ever wondered how to interpret regression coefficients in big data? Today, we delve into this intricate yet fascinating world. Picture this: you're faced with a sea of data swirling with countless variables. How do you make sense of it all? Enter regression coefficients. These are the constants that transform your input variables into a predicted outcome in a regression model. They're like the magic keys that unlock the patterns hidden within big data. Each coefficient indicates the mean change in the response variable for every 1 unit change in the predictor variable, while other predictors are held constant. Importantly, these coefficients help us to predict future outcomes based on the data we have at hand. They're the cornerstone of data analysis, allowing us to make informed decisions in a wide range of fields, from finance and economics to healthcare and environmental science. Understanding regression coefficients forms the basis of interpreting results in big data analysis. So, ready to dive deeper into the world of regression coefficients? Let's unlock the secrets together. Dive deep into the components of regression coefficients. In the realm of data analysis, regression coefficients perform a starring role, helping us understand the relationship between variables. These variables can be broadly categorized into two types: dependent and independent. Dependent variables, as the name suggests, are those that are the focus of our study. They are the outcome variables that we're interested in predicting or explaining. For instance, if we are studying the impact of temperature on ice cream sales, the amount of ice cream sold would be our dependent variable. On the other hand, independent variables are those that we believe have some effect on our dependent variable. Continuing with our example, the temperature would be the independent variable because we hypothesize that it influences ice cream sales. Now, let's imagine these variables interacting within a regression equation. It's like a dance where the dependent variable is swayed by the independent variables. The regression coefficients are the numbers that quantify this dance. Each coefficient tells us how much the dependent variable is expected to change when the corresponding independent variable increases by 1 unit, holding all other variables constant. So, in our ice cream example, the coefficient of temperature would tell us how much we expect ice cream sales to change for each 1 degree increase in temperature, assuming all other factors remain unchanged. These coefficients are key players in our analysis. If a coefficient is positive, it means that as the independent variable increases, the dependent variable also increases. Conversely, a negative coefficient indicates that an increase in the independent variable leads to a decrease in the dependent variable. But remember, correlation is not causation. Even if there is a strong relationship between two variables, it doesn't necessarily mean that one causes the other to change. To make sense of these coefficients, it's also crucial to understand the concept of statistical significance, which we'll discuss in the next scene. These variables play a crucial part in determining the regression coefficients, thus impacting the overall analysis. Now that you know what regression coefficients are and their components, the next stage involves interpreting them. To put it simply, the regression coefficient is a statistic that represents the extent to which variables change together. The sign of the coefficient, whether it's positive or negative, indicates the relationship between the variables. If the coefficient is positive, it means that as one variable increases, the other does too. On the other hand, if the coefficient is negative, it indicates an inverse relationship. As one variable goes up, the other goes down. But it's not just about the sign. The value of the coefficient also matters. The larger the absolute value of the coefficient, the stronger the relationship between the variables. For instance, a coefficient of 2 means that for every unit increase in the independent variable, the dependent variable increases by 2 units. However, and this is crucial, the context is king when interpreting coefficients. Without fully understanding the data and the nature of the variables, you might miss out on important nuances or even misinterpret the results. So remember, Interpreting regression coefficients isn't just about numbers and signs, it's about the story those numbers tell within the context of your data. Interpreting regression coefficients correctly can provide valuable insights from big data. To recap, we've explored the world of regression coefficients in big data. We've unraveled what regression coefficients are, delved into their components, and learned how to interpret them. We've discovered that these coefficients are more than just numbers. They're valuable tools that help us understand and predict patterns within vast amounts of data. Next time you encounter regression coefficients, remember, they're not as complex as they seem. Keep exploring, stay curious.